All right, so we're in the last of the four sessions for the Knowledge Machine for our Night Science Book Club, and we're kind of wrapping up this incredibly exciting, I think, very interesting book. Lots of good ideas in it, lots of stuff to talk about. So in this last section, we're dealing with chapters 11 through 14, which is really a little bit about the history of the Iron Rule and Strevens's concepts around how science came to be, and then some forward-looking in chapter 14 about the care and maintenance of the machine. And so, yeah, so let me kick off sort of by asking, if you had any general thoughts or observations from this part of the book, or anything that comes to your mind. I mean, one of the things Strevens argues is that the rule was relatively late, right? I mean, I mean, humans have had the same brains for tens of thousands of years. Why did it take till the 17th century for us to start exploring the world in a way that led to, or excuse me, to all the advances that we've seen? Why did it take so long?
Mm. Difficult. Now, to be fair, to be honest, I read this chapter like a month ago already, so I
Uh-huh.
kind of forget his argumentation on the thing. I like I'm personally still under the impression that it has a lot to do with also technological innovation and things like that. But I really I can't remember exactly what his argumentation was. Whether it was also maybe about the mindset and the culture, because I
Yeah.
know he talks a lot about this split mind, and he like Newton is kind of the embodiment of that.
And
Um,
yeah, I
so
think his core argument is that it's that the iron rule is so counterintuitive, right? That are, and I have to say this, I remember this as a child, as I was beginning to learn about what science is and what it isn't, and what religion is and what it isn't. And I think we have an intuition that, at least that's how I remember these experiences as a kid, about the world and how it fits together. And that's not really the iron rule doesn't, right? It doesn't care about that. So if you use sort of notions of harmony or culture or even religious ideas around how things fit together to guide your exploration of the world, then you're not. That's not the iron rule, right? You're gonna do other things.
Hmm.
I mean, I think it's, certainly when I was growing up, one of the sort of clashes that were thought to be dominant in the world was the clash between sort of the natural view of things and the technological view of things, right? And this idea that the technology was abandoning nature and a harmonious way of being in the world, right? Which is kind of idolized. I mean, if you look, if you read Tolkien, for example, right? The elves are in tune with the nature, the hobbits are in tune with the nature, and the people who are clearly not in tune with nature, are the orcs and their friends and relatives. So then if you're drawn to that nature harmony, are you able to do the kind of science that you need to do in order to build the technology that you were just talking about?
Hmm. Hmm. And I'm not sure. I'm not sure whether. So on the one hand, you do have technology, but on the other hand, you also have just empirical observation. And I think in general, I mean, your view of the world and your understanding of the world is still based on your observation of the world. So in that sense, I don't find it that counterintuitive in some ways, this adherence to empirical facts, because I know that if I put my hand in the fire, it's going to burn me. So in a way, that's already taking one step towards like an empirical mode of thinking. So I'm not sure. Yeah, yeah. but now I'm not sure how to answer this question about technology itself. But I was struggling a bit to buy the like counterintuitiveness of the iron rule. Um, yeah, I'm not sure. Mm, yeah, I'm
I
also
mean,
not sure if
yeah.
yeah.
I mean, one
No.
example in for me about this comes from, for example, evolution, right? So when again, the way I grew up in biology, um, the thing that attracted me to biology or any kind of science was this idea that there were these beautiful, rational, logical models of how things worked that had strong explanatory powers, right? A growth factor hits a receptor, a protein changes shape, a tyrosine is phosphorylated, a new protein docks, and a cascade goes out, and it's beautiful and it's reductionist and so on. But actually, that mental model will only get you to a certain point, and it's not a very far point, right? Because actually, what's going on is so much more chaotic and redundant, right? And so when you look at evolution, for example, evolution is it's a mess. It's a horrible mess, right? And all kinds of complexities are there, and there are like I mean, now we're discovering all these RNA levels of regulation and so on. I mean, and it's just so much, and it when you think of it through an evolutionary perspective, you can kind of understand, how do you get more than one gene? Well, you kind of duplicate one that you have, and you kind of it changes in some awkward way to fulfill a new function. But that's not how you would build it from scratch if you were going to build something to do that, right? And so that's totally counterintuitive. And I think this is part of what informs the debate around evolution, right? I mean, Dawkins wrote The Blind Watchmaker, and his point was that yes, what comes out is very functional and amazing, but not necessarily the way you would build it if you were an intelligence, right? So that for me is, but all the empirical data supports evolution. So my intuition about how biological organisms should actually be formed is completely irrelevant.
Right. I see, but I feel like you still need some sort of um all I mean even Newton was aware that his theory was not didn't exactly correspond to the observations that he saw. Already he knew that he had errors, but he was like happy enough with it because it was kind of functional. Um, so I think through these sort of theories, there's still a coexistence of trying to find harmony within the observation. But I guess you have to accept that the observations cannot be tightly put into boxes as you want to put them into, I guess, which is maybe this counterintuitiveness. I'm not sure.
Yeah, and I would agree with you. I think we're naturally drawn to bringing some harmony into our work, right? Otherwise, the world becomes a very scary and hard to understand place.
Not
Um,
only that, I think you also need the theories to actually be able to predict something. Otherwise, your observations are not functional. So,
Interesting. Yeah. So that actually, let's jump ahead to that point because that comes up a little bit later, which is this, and actually relates directly to night science, right? So this argument that was in the literature a few years ago between Itai and Martin and this group of authors around the whole idea of a hypothesis-free data exploration, right? So in the strongest form, Martin and Itai put forward this idea that you should, in addition to all the other things that you do in the day science thing, you should also occasionally just take some data and explore it in a hypothesis-free way. And these other authors said, well, that you can't do that. That the human mind is not capable, which is kind of what you just said a moment ago, right? You can't look at data and not have some hypothesis. It's like, right? I mean, would you agree with that? If you look at data, does a hypothesis automatically suggest itself?
yeah, well, also that, but also I think even looking at data assumes that you're looking at it in some form, and deciding what form the data takes is also based on some sort of hypothesis, whether it's explicit or implicit. So I agree with that view.
Yeah, and okay, I agree too. I mean, what Itai and Martin said in response to this criticism was, well, that's a very broad. view of a hypothesis, right? That's sort of like hypothesis in the air, hypothesis in the water, right? It's in our environment. You can't get away from it. And at that
Mm.
level, I think they would agree, but I think they were redefining it more narrowly. And of course, night science suggests there's a iterative data hypothesis conversation, right? So you have a hypothesis, you look at some data, and then you refine it, and you go back around and around. So, yeah, yeah, interesting.
Mm.
So I think humans doing science will always have these issues, right? Because we're not we're not capable of being pure iron rulers, right? We're not. That's too difficult. That we're just not equipped. Except maybe there are some of us, right, who are perhaps they're sociopaths. They can do that.
Is hypothesis-free science the same as conducting science without making any prior assumptions, or is that distinction?
Well, I guess they're overlapping. I'm not sure they're necessarily completely contiguous or completely overlapping sets, right? You could still have a hypothesis but no assumptions, right?
Yeah, okay, that's true. Okay.
Yeah, yeah, and I think in social sciences they try very hard to be sort of rigid with all that stuff, much more than we do in the experimental sciences, right? Yeah. So what about Strevens's concern? So when he is forward looking, right? He is he's worried about the iron rule and people trying to meddle with it, right? Which is inherent in human kind. Are you afraid of that? I mean, particularly interesting to me as I, read these chapters and thought about it in the current climate, where certainly here in the United States, politics is getting very involved in science.
You're asking whether you're worried or we're worried that the iron rule cannot be upkept or upheld?
Yeah, that it can be messed with, or it can be weakened or bent into some kind of ideological shape that it shouldn't be in, right?
Um,
I mean, if you look at history, right? So there's a really good example in history, right? Stalin was very fond of this biologist Lysenko, whose evolution theory of evolution was at the time perhaps still, I mean, really not justifiable. Obviously, this is after Darwin, but he had this idea that, for example, if you become a blacksmith and your muscles grow because you're doing a lot of hammering of metal, and then you have a child, then that child will have big muscles, right? The sort of this inheritance of whatever, of adapted, of these. That was his idea, and of course, under Stalin, millions of people starved in Russia because their agricultural programs were based on this kind of thinking, right? So that to me is a really good example, a very scary example of how they just threw the iron rule out for a while and subjugated science to political ideology.
yeah,
But science didn't care. Plants did not adapt. They were not, they were not ideologically influenceable.
yeah.
I mean, I think we can go back to Michael's idea about this Baconian convergence sort of thing. So, I mean, you can, yeah, if you have some sort of regime that starts ignoring their own rule, you'll just start making bad decisions if you base it off of science that ignores the iron rule. So I think over time this will become evident because, again, I think you have to come back to the fact that science has to be functional, sort of. In the end, I think all of science, the end goal is somehow to manipulate reality in some way that's useful to us. And then if you fail to do that, then obviously something's wrong with the science, and that will over time correct itself. Or the system will be so bad that it won't matter, I guess, or that it will destroy itself. But
Yes.
I think just empirically speaking, things will converge eventually.
Yeah, I agree.
So
Yeah.
I'm not, yeah. So in a way, I wouldn't be worried about the iron rule in that sense. Um,
Okay. So I think if I may, it sounds to me like long term you're optimistic because it will correct itself, right?
yes. Yes, or the values will be so shifted that then
Yeah.
There's no homeostasis here. It's self-regulating. The whole system, maybe.
Yeah. Yeah. But I guess short term, we don't know. I mean, it could still, in terms of the fates of some of the humans involved, it could still be extremely painful. Um,
Yeah, without a doubt.
true. Yeah.
If being at the forefront of science becomes a matter of national security, as it might be right now, then yeah, this will lead to some casualties, perhaps.
yeah. Yeah. I mean, what is the perspective of what's going on in the US? I mean, I don't want you, I'm not asking you to speak for all of European science, but I'm just curious. When you look over the pond at us and you think, what do you think? I mean, what do you think?
Yeah.
It's okay, you don't have to answer. I don't want to put you on the
EU
spot.
government. But maybe, can you maybe sketch your view of the situation in the United States so that we can juxtapose ours?
Sure. I mean, look, my perspective is that we are seeing an unprecedented level of political interference, right, in science. I mean, the beauty of what happened in science after the Second World War was a combination of massive investment over time and stability, and the willingness to let the scientists get on with it, right, in terms of their own ecosystem, which had its weaknesses and its flaws and so on. And this is by no means the first time political interference has happened, right? I mean, George W. Bush, for example, famously redlined a small number of grants, like a dozen or so. I mean, really small number, but things that were particularly ideologically troubling to him. If whatever. But now it's really unprecedented, right? And particularly with people like Secretary Kennedy, we're moving away from evidence-based medicine. So he clearly is not a believer in the iron rule, or even in the scientific method in its most sort of simple form. And I agree with you. Over time, it's not going to change how infectious diseases work. If we stop vaccinating, there will be consequences. Eventually, people will wake up to it, and then, if there's still the opportunity, we'll correct it. But yeah, that's my perspective. And I mean, to me, it's shocking because it's complete lack of understanding of the role of science certainly in this country, which is an enormous engine of economic prosperity and societal advancement, right? Health advancement and all kinds of other advances. Plus, look at all the tech that's come out of it, right? I mean, if you take science in the broader sense, you know, you can't really say America has not made amazing contributions, right?
Yeah, yeah.
So should we stop? I mean, why?
Yeah, if I may, if I maybe contain myself only to the situation in the Netherlands,
Yeah,
I can see that the amount of influence that politics has on science in the way that is happening in the US is not as far progressed here, but you do already see that politicians are able to select their own views of science. But this is more of a societal change, in where it used to be that science would maybe held in a bit of a higher regard, or there was more trust in the system, and now this lack of trust can allow politicians on different sides of the political field to cherry pick the results that corroborate their worldview already. So, for example, in carbon monoxide pollution in the Netherlands, we essentially have been stuck for 10 years in being able to build new housing, because we're just not sure whether or not we can upkeep the amount of housing that we need, while still keeping the environment in sort of a balance. And there's no longer a ground truth for that. Even institutes that are funded by the government, or have been traditionally seen as well regarded or peer reviewed, that doesn't matter anymore, because you can just find different institutes that corroborate your findings. So that's one thing. And perhaps in terms of funding, we are losing a bit of funding in science and in education. So that is some political influence. But I find that the exclamations that maybe Robert Kennedy is making, or the pressure that is being exerted on American universities, is on a very different scale still.
Yeah, yeah.
I don't know if that's also how you experience that, or I don't know if that's similar in Croatia.
Yeah, yeah. No, I mean, thank you for sharing that. I mean, it's and it's probably always sort of been like that. I mean, politicians have certainly bent scientific truth to their own political
Yeah, that's true.
ends
That's
for always, and certainly when we've seen totalitarian regimes, like in Germany, for example, you know, science became very much a a tool of government, right? Not a thing in and of itself. It was there to prove the truths that the government already espoused, right? So no, definitely.
that's true.
Yeah, yeah. So well, who knows? It's your generation that will have to deal with it. I'm old and almost retired, so no. I mean, I'm sorry. I'm apologizing. I'm sorry.
No. It's no. Yeah.
Um, okay. Anything else about this part of the book that you want to talk about? I'm curious. Anything else that sort of struck you, or just in general comments about the book as a whole? I'd love to hear.
Yeah. Well, I don't know. I felt I guess we didn't criticize the book too much, but I personally um I don't know, at points of the last couple of chapters, I feel like he was reiterating a lot this idea a bit about the split mind. Then like this, I forgot the term he used, but sort of the sterilization of communication in science. And I like those points, but I felt like he was reiterating them a lot. I also felt like the claims he is making are not necessarily opposed to Popper, which he keeps mentioning as his enemy. So I don't know. I found it a bit unconvincing near the end. I didn't see the points he was making anymore. I felt like he was just reiterating some of the points in slightly different contexts, and
Yep.
that was so yeah, I don't know.
Yeah, I would agree with you. I think it's, I mean, the book could have been a bit shorter, right? And it could have been a bit more concise. And I think the sort of, you know, I think to try and make a dramatic argument, he puts up straw people, you know, that he can argue with. I think that's probably a literary device, which may not be that well executed here. But okay, interesting. Yeah. Yeah, I mean, what I personally took away from it at the end was really just this idea that empiricism, right, is this is his idea, and I think it makes a very cogent argument for why it appeared late. I have to say one of the things, one of the metaphors that I really love in here is the coral reef, right, and the scientist as the polyp, and the idea that you know, we in our scientific careers we create data and we deposit that as a piece of the reef, but the soft squishy parts, which might be our interpretation of it, are ultimately disappear, but we leave something tangible behind. And I think that's an interesting way of looking at how science builds. It's probably not a completely accurate time, because I think, and maybe AI will fix this for us, we don't really spend a lot of time going back and looking at data from, you know, 20, 30 years ago, right? It's not like, so we're sitting in the coral reef, but we're not really looking at what we're sitting on. We're just looking forward or upward or whatever.
Mm.
Maybe, you know, yeah, I don't know. Did you think that metaphor was interesting? I just in love with something stupid.
No, I agree. I think it is a nice metaphor indeed. And what you said about AI fixing it, yeah, I'm not sure it could be AI, but also I think now the way data is collected, it's done in a much more systematic manner and making it more accessible. And yeah, so I think in those terms it will improve. And I definitely, yeah, I definitely agree. It's really building on top of knowledge.
Yeah.
Yeah, that's an interesting point. I guess now that data are more, right, I guess people are using digital lab books and online databases and things that are going to be much more accessible. Maybe that reevaluation of prior data might actually happen more routinely than it would if it meant going into the bowels of your library and photocopying papers from 30, 40 years ago.
Yeah.
Yeah, kind of indeed. I went to a conference last week where a lot of the talks are, we first reproduced this work and then we, with the data set that they used, and then we went forward with the data, which is kind of cool.
Yeah, that is cool. Yeah. So how is it now in data science? Are people doing a good job of of publishing and making accessible their data and their algorithms and their methodology? Is that happening? I mean, I know that's the ideal, but is it actually happening or?
In terms of code, I'm quite happy. I think in the last 2 years, I've maybe come across 3, 4 papers that had their code in some sort of weird private repository, or not on GitHub, but with authors that then don't respond to emails. But GitHub is quite standard now, and documentation is getting way better. Even now, a bit bloated with all the AI generating doc tools. So I'm happy in that regard.
I agree. Yeah.
We do still have PhD students here in the lab that do a PhD on how to actually also annotate metadata or variables, or that you might not instantly report, or it is in the right format to host on a public database, but is still very important for final result interpretation. So it's not an unsolved problem.
This is good. That sounds great.
Yeah.
Yeah. And there are benchmark papers that try to also create repositories of data sets to test on and so on. So create kind of a fair ground for testing.
Yeah.
But that also takes time. Like as a specific field develops, you get more standard data sets and so on.
Yeah, that's true.
But yeah, I think it's relatively positive.
Yeah, it's going the right direction for sure.
That's great. That's great to hear. Yeah, I mean, I wish the people doing the wet biology would get better at it, but it's a little harder. It's a little harder, right? Cool. All right. Any last thoughts on the book before we wrap up?
Not per se on the book, but I would say that we have a retreat every year with our group where we also we spend a few days with the group in some house, and we also do make presentations. And then we were organizing this year and decided we should do philosophy of science from the topics. And then 2 PhD students got that topic and also used the book, or at least the first few chapters, at least Popper and some sort of definition of science. I'm not sure if they even touched upon iron rule. I don't recall anymore. But it was quite cool to have that discussion, and it was also fun to see. It was like an hour or so presentation, including discussion, how varied opinions were on what science actually is. Also showed me that it's not really uniformly taught anymore in like academic schooling, because there was not really a uniform train of thought, and I also noticed that there was definitely different prior knowledge bases on this topic. So which was a bit weird for me. I would have loved in the bachelor to also have more of a meta view on what science actually is, or what is the system that we're actually engaging in. Yeah. That
is really interesting. Thank you for sharing that. Yeah, I mean, I'm not sure I was ever formally taught what science is. There were, I mean, at the university I attended, there were courses on the history and philosophy of science where that would have probably been covered. But for people who are interested in becoming scientists, that was not obligatory, right? We didn't have to do that. So it's just, we just assume people know what it is. Yeah. Sorry, go ahead.
What do you think about that? I mean, do you think, I sometimes wonder, it's a bit insane that we're kind of scientists and half of us didn't even have courses on what science is.
Yeah, I mean, that's part of the reason of the Night Science Workshop, right? I mean, we kind of talk about what science is, and not in terms of the detailed practicalities, but in terms of what it is, in terms of ideas and the interplay between the night and the day science, in our particular dichotomy, in our way of thinking. And that we kind of start the workshop with that discussion about what is science, right? And it's, what is it? And most people initially start off with a definition that's purely day science, which is, the whole front of this book, right? And we don't, I don't know. I mean, in a way, it's kind of weird. I don't know, for example, if you had an engineering degree or a mathematics degree or something, whether someone would sit down and say, what is mathematics, or what is, I don't know. Yeah.
My supervisor called all doctors engineers recently, and he was very stubborn about this. But yeah, so I guess there's still some leeway to discuss.
You know, my brother studied history at college, and I do think they talk a lot about what history is, right? The practice of the discipline, right?
Yeah,
Historiography and all these kinds of things, and what are sources and what's written down and all these kinds of things.
exactly.
So I think there's an opportunity. And I mean, if you ask me, yeah, of course, I think everybody should learn about night science or creativity at some point, you know, maybe even as an undergraduate, right?
Yeah,
And that is one way of thinking about what is science exactly. So yeah.
yeah. I think it also relates a bit to a recent event we went to that was regarding the introduction of AI or large language models into education, and then you certainly have to educate how to use AI in your daily science, but then the lines get very blurry on like what parts are supposed to use or supposed to do by yourself, or what parts can you get help with, and it's still science, but there's really no prior foundation on what was actually science before the introduction of LLMs to this whole thing. So it all feels kind of arbitrary and based on opinion of the lecturer, uh, which yeah, it muddied. That's fine, but it muddied the conversation a lot. It definitely slowed down the whole process. So I felt like as a university we're not quick enough to adapt to differential or differing circumstances.
Yeah. Yeah, it's super hard. I mean, it's happened very, very quickly, right? And opinions are differ so wildly on the whole ideas of how AI should interact with knowledge and things like that. So yeah, no, definitely that there's a I mean maybe Michael Strevens will write a new edition of his book with AI taken into consideration.
Mikey. That'd be cool.
Yeah.